Hello guys, welcome back to this channel. This is Mr. Electric. You are seeing Mr. Electric. This is the face behind all these faceless videos. If this is your first time watching my video, make sure to like, subscribe and turn on the notification bell so that anytime I drop a video, YouTube is going to notify you. And in this very video, I'm going to talk about contactor interlocking. And what is contactor interlocking? Contactor interlocking is a safety mechanism used in electrical system to prevent two or more contactors from being energized. That is contactor interlocking. We don't want two or more contactors to be working at the same time. Hence, interlock is needed. Bear in mind that we have two main types of contactor interlocking. We have one as electrical interlocking and two as mechanical interlocking. And in this very video, we are going to be making good use of the electrical interlocking. So guys, as I said earlier, if this is your first time watching my video, make sure to like, subscribe and turn on the notification bell so that anytime I drop a video, YouTube is going to notify you. Stay tuned as we make progress. We are actually going back to the studio to practically do set connection. And guys, before you go back to the studio or the workshop to practically build set a circuit, interlocking circuits, you have to bear in mind that we have a lot of circuits that needs interlocking. And I'm only going to mention only three. We have a lot of them, but I'm going to mention only three for you. We have the forward and the reverse system. There's interlocking between these two contactors. That is the forward contactor and the reverse contactor. That is one. We have the star delta starter. There's interlocking between the star contactor and the delta contactor. That is two. And finally, the ATS. That is the automatic transfer switch. Let's say we have two power systems. That is the power grid and the generator. We don't want these two power to be running at the same time. Hence, there's ATS needed. Whether it is a changeover or the automatic transfer switch, that is the circuit is going to change from one form of power to the other. Let's say you are using the power grid and there is a light off within that power grid system. The automatic transfer switch is going to automatically shut down the power grid and then turn to the generator or the solar. That's the ATS or the manual changeover. You are actually going to switch from one power source to the other. That is that, guys. We have a lot of them, but I've actually given out three. Guys, this is the practical video. And with the practical video, we are going to consider the forward and the reverse control circuit. And with the forward and the reverse control circuit, we have two contactors, serving as the forward and the reverse contactor. And this contactor you see here is the forward contactor, and this one is the reverse contactor. And in the same way, I can also say this is KM1 and this is KM2. We also have this yellow push button here as the start for the forward contactor, and this green push button as the start for the reverse contactor. This is the stop push button. We have normally closed switch beneath the push button. This is the push and this is the switch. Number 1 and number 2 7 as the normally close, and this number 3 and number 4 7 as the normally open. And with this one, the same number 3 and number 4 7 as the normally open. Normally open switches are made for starting, to start a contactor or any other load. And normally closed switches are made for stopping load. You also have this single pole circuit breaker here for safety purposes. And over here is the wiring diagram. We have this as the circuit breaker. This is the circuit breaker. This is actually the phase. And down here 1 and 2 as the normally closed switch. This is the normally closed for the stop. We have 3 and 4. This is the start push button for the forward contactor. Now look at this. The whole of this place is for the forward contactor, and this side is for the reverse contactor. And as I said, this is the start push button for the forward contactor. You have it at this place, the 3 and 4. And this side is the hold on. And over here is normally close contact. Now look at this. We have K1, that is the forward contactor. The same way we have F as the forward contactor, and over here we have K2 as the reverse contactor. And at the same time we have R over here as the reverse contactor. We have K2 at this side, but this is K1 as the forward contactor. This is the reverse contactor, K2. In order for us to energize this forward contactor, the normally closed contact on the contactor is being used to energize the forward contactor. That is the interlocking. There's interconnection between the two contactors. And this is the electrical interlocking. With the mechanical interlock, you could see that there's another device placed between the two contactors. That is going to prevent simultaneous operation of the two contactors. And with electrical interlocking, there is interconnection between the two contactors. Now, this is A1 and A2. And in order for a 220 volt load to work, there must be live and neutral. So the neutral is already connected to A2. And this side is the live. And technically, this is the source wire coming to the A1. And this source wire coming to the A1 must pass through the normal closed contact on the reverse contactor before coming to the A1 to energize the forward contactor. And this side too is the reverse side. This is the start push button for contactor. This side is the hold on. And over here 21, 22 NC. This is contactor 1. This is contactor 2. But you have contactor 1 terminal used at this side. And this side simply means that before the source wire coming to A1 to energize this contactor, that is the reverse contactor, it passed through the normal closed contacts on the forward contactor before coming to the reverse contactor A1 to energize the contactor. And that is the interlocking. This side. And guys, make sure to stay tuned as I make progress. You could see that we have 13 and 14. That is the normally open terminal for the hold on. You could also see that this side we have 21 and 22. That's the normally closed contact. And this type of contactor is called auxiliary contactor. A contactor that has the normally open and the normally closed terminals on it are called auxiliary contactor. That is what we have here, normally closed, normally closed. And this side is the interlocking. So guys, make sure to stay tuned as I make progress. This is a 220 volt contactor. You see that we have 220 volts at this side. Before this contactor will work, there must be live and neutral connected to the A1, that is the live, and A2, that is the neutral. There must be live and neutral connected to these terminals before it will energize. So guys, what I will do is to connect my neutral to A2. This is the live, the circuit breaker, and this is the neutral connector. There's a neutral signal over here. So what I will do is to connect the blue cable from this terminal to A2 and then loop it to this A2 over here. That's the neutral. We'll use another blue cable to loop the same neutral signal to this A2. We are done with the neutral connection. What I have to do is to use a brown cable for the forward contactor wiring. We are going to use this brown cable. I'll connect from the circuit breaker to the stop push button. We have the stop push button over here. Okay. This is the forward contactor push button. I have to connect the live from the stop push button to it. Okay. Now, this is normally closed push button for stop. When I turn on the circuit breaker, there's going to be a current flowing from this side to this side. This is normally closed, so automatically there's a link between number 1 and number 2. There's a link between these two terminals. So when I turn on the circuit breaker, current is going to flow from this 1 to 2 and from 2 to number 3. This is normally open, so the current is going to be trapped at number 3. When I push it before, the current is going to flow from 3 to 4. That is the way normally open push button works. So what I have to do is to connect a cable from 4 to 21. This is the forward contactor. So right now this cable from number 2 has been connected to 3. You have 3 at this side. This is number 3. And I have to connect a cable from 4 to 21. This is number 4. This is a switch, the start push button from 4 to 21. And this 21 could be found on the reverse contactor. This is the reverse contactor. So when I connect a cable from 4, how to take it to 21? You have 21 at this side. 21. And then I use another cable and connect it to 22. From 22 then to go to A1 on the forward contactor. That is the interlocking. So I'll use another cable that is also brown. Connect from this side. This is 21. Okay. And from 22 to A1, I also use another brown cable. This is 22. This is A1. So guys, this is the interlocking. We are only done with this straight line. Now let's assume that we don't have this side, the hold on side. We don't have it. These components you see here are going to be in series. From this switch to this switch, from this switch to this contact, and from here to A1. All these things are in series. And without the hold on, when you push the start push button, the contactor is going to start. But then when you remove your hand, it's going to stop. That is without the hold on. So without the hold on, these components, as I said, are in series. This hold on you see here is what is going to create a parallel flow of current to the contactor. Now let me turn on the circuit breaker and watch out. This is without the hold on. The forward contactor is working perfectly. But then when I remove my hand, to go off. So what I have to do is to do a hold on for the forward contactor. We are done with the interlocking with the forward contactor. What we did is that this 4 terminal you see here, this is number 4. This wire you see here is the forward contactor switch wire. And before this switch wire is being connected to A1 on the forward contactor, supposed to pass through the normally closed contact we have on the reverse contactor from number 4 to 21. This is the 21, and from 21 we picked it from 22, and from 22 we picked it to A1. This is A1, and we have the neutral connected already. So when I push it, it's going to start. That is the interlock, and we will do the same thing for the reverse contactor. Just watch out. Now we are going to do this hold on. So right now, as I said, the circuit is in series. When I release it, it will go off. When I push it, to go off. This is without a hold on. And what you have to do is to connect a cable from number 3 to 13, from 4 to 14. This is the start push button for the forward contactor. So what I have to do is to connect a wire to number 3 and from there to 13. The same way, a wire to 4, from 4 to 14. That is the hold on for the forward contactor. And when I do this, before the contactor is going to hold, when I remove my hand, it's not going to go off. That is the importance of the hold on circuit. I have a video about contactor hold on, and I'm going to leave the link in the description down below. Just go to the description, you tap on the link, and it will take you directly to that video to watch it. A contactor hold on video. So what I have to do is to use another brown wire and connect from 3. Safety first, so I have to turn off the circuit breaker. This is number 3. From 3 to 13, you have 13 at this side. This is 13. Okay. Now from 4 to 14. You have 14 at this side. 14. Okay guys, we are done with the hold on. Now let's turn on the circuit breaker and operate it. Okay, so right now it is working perfectly. This is the forward contactor. There is a hold on. This is the importance of the contactor hold on. It is going to hold the contactor for you. You can just push it once and then it's going to work. I can use the stop push button to turn it off. Okay. So right now what is happening is that the current is being trapped at this side. And because I've used this cable as the hold on to number 13, there's a current also trapped at number 13. And when I push the push button, the current is then going to travel from 13 to 14. And this switch wire will take it to number 21. And because it is normally closed, directly there is a current at this side. When I push it, the current will automatically be transferred from 21 to 22. And from here, this cable will take it to A1. That is what is happening when I push the push button. And when I stop it, there's a current at this side. This is the switch wire. That is what is taking the current from this side to this side, from this side to A1. And now, let's turn off the circuit breaker and work with the contactor and the push button. What we have to do to the push button is to connect a live signal to it. And you could see that in the wiring diagram, there's a live from number 13 to number 3. This is the start push button. There's a live from this side to this side. You can also pick the live from number 3 to this side, number 3. It is the same thing. Or number 2 to number 3. It is the same thing. I can just cancel this wire or this line you see here and then take it to number 3 or even take it to number 2. It is the same principle. And we are going according to the wiring diagram. So what you have to do is to connect a cable from number 13 to 3. And with the reverse, we are going to use black cable for the wiring. This cable is to pick the live signal from number 13. As I said earlier, 13 to number 3. So what I have to do is to open it and then loop the live. This is number 3. We have looped the live from 13 to number 3. And we have to connect a cable from 4 to A1 on the reverse contactor. And before this cable reaches A1, it's supposed to pass through the forward contactor normally closed before it will come to the A1 on the reverse contactor. That is the interlocking. You could see that we have the number 4. This is the start push button for the reverse contactor. We have the live connected from 13 to number 3. And from 4 to 21, that is the normally closed contact on the contactor number 1. That is the forward contactor. From 4 to 21, and then we pick it from 22 to the A1 on the reverse contactor. So what I have to do is to use this black cable and connect from 4 to 21. Okay. This is the 21. And as I said, the 21 you see at this place can be found on the forward contactor. That is for the interlocking. This is the reverse contactor. We have 21, 22 as normally closed contacts. Okay. And then pick it from 22 to A1. Guys, we are done with the interlocking. It has left with the hold on. We have interlocking between the forward contactor and the reverse contactor. That is the electrical interlocking, interconnection between the two contactors, the forward and the reverse. So right now we have this normally close found on the reverse contactor. That is K2. This is K2. Now the normally close found on the reverse contactor. And this is normally close. This normally close you see here can be found on the forward contactor. That is K1. So guys, that is how to do interlocking. Now, without the hold on, let's operate the circuit. This is without a hold on. And let's see the one that is having the hold on. Okay. That is the importance of a hold on. And as I said, I have a video about contactor hold on, and I'm going to leave the link in the description down below. When you go to the description, just tap on the video link and it will take you directly to that video. Now let's connect the hold on. Safety first, I have to turn off the circuit breaker. So what I have to do is to connect a cable from 3 to 13 and another cable from 4 to 14. It is the same principle we have on this side. This is 13 as the hold on. We have the 14 at this side, another cable from 4 to 14. We have 14 at this side. So guys, we are successfully done with the interlocking. Now, let me turn on the circuit breaker and then we operate the circuit. Okay. So right now there's a current trapped at this side. Because of this hold on wire, there's a current trapped at this side too. That is 13. Now when I push the start push button, the current is now flowing from this side to 14 and from 14 to this side. And this is the switch wire passing through the normal close contact we have on the reverse contactor. This is normally closed, so automatically there's a flow of current from this side to this side and from here to A1. And because we have the A2 connected with neutral, the contactor is going to start working. Now, let me push the reverse push button and see what happens. You could see that the reverse contactor is not energizing. It is because of the interlocking. The interlocking is preventing simultaneous operation of these two contactors. We don't want these two contactors to be working at the same time. Hence, interlock is needed. Now, when these two contactors, one is serving as the forward contactor and the reverse, When this contactor is also able to energize, there's going to be a short circuit in the power cables to the motor. That's why we are doing the interlocking. And the reason why this push button is not working is that we have the switch wire. This is the switch wire. This is the hold on. The 14 and the 13 is the hold on, this cable. And this is the switch wire to 21 and from 22 to A1 on the reverse contactor. And because this contactor has energized, right now the normally close is no more a normally close contact. Because it has energized, the normally close has turned to normally open. So this contact is now serving as normally open contact. But technically it is normally closed. But because the contactor has energized, it is serving as normally open contact. And that is why there is no flow of current from 21 to 22 and from 22 to A1. And that is the main reason why when I push this reverse contactor push button, the contactor is unable to energize. Let me stop it and then push the reverse push button. So right now this contactor is working, and at the same time when I push the forward contactor push button, it is not going to work. And as I explained, this is the forward contactor. Now before this switch wire is being connected to A1, it's supposed to pass through the normally close contact we have on the contactor 2, that's the reverse contactor. The switch wire coming to the A1 is being connected to normally close contacts we have on the reverse contactor before coming to A1. As simple as that. That is the interlocking. We have interchanged the switch wire connections. This switch wire coming to A1 is being connected to the normally close we have on the reverse contactor before coming to A1. And at the same time, we have this switch wire coming to A1, that's the reverse contactor, being connected to the forward contactor normally closed before coming to A1 we have on the reverse contactor. That's the interlocking. Guys, thank you for watching my video to the very end. That is how to interlock a magnetic contactor. If you find this video helpful, consider subscribing to this channel and turn on the notification bell so that anytime I drop a video, YouTube is going to notify you. Thank you once again and see you in my next video. Bye bye.